SRAM. This is the static random access memory, one of the fastest forms of data storage inside a computer. Unlike standard memory, it uses multiple for every single bit of data, allowing it to hold information constantly without need to be continuously refresh the processor. Its near-instant speed ensures that the computer's brain never has to waste precious cycles waiting for its next instruction. DRAM. Dynamic Random Access Memory is the baseline technology behind the main memory stick, found in almost every modern computer, smartphone, and gaming console. It stores each bit of data inside a microscopic circuit consisting of a single transistor and a single capacitor. Because capacitors naturally leak electricity, this memory must be dynamically refreshed thousands of times every second to prevent data loss. This constant refresh makes it slightly slower than static memory, but it's very vastly cheaper to produce in large capacities, making it the perfect middle ground for system memory. SDRAM, Synchronous Dynamic Random Access Memory, arrived in the 1990s to solve a massive bottleneck in computer performance. Old memory types operated independently on the processor, forcing the CPU to set idle while waiting for data requested from the motherboard. This updated version synchronized its internal clock cycles directly with the computer's central processor by matching the system's exact rhythm. It allowed the computer to queue up commands and stream data continuously, drastically improved multitasking and system efficiency. DDR, Double Date Rate memory, represented a massive evolutionary leap for system performance at the turn of the millennium. Instead of sending data once per clock cycle, this architecture managed to transfer data on both the rising and falling edges of the clock signal, effectively doubling the bandwidth without increasing clock speed. This breakthrough established the naming standard for modern memory generation, moving from the original desktop models through iteration like DDR4 and the current ultra-fast DDR5 standard. LPDDR, low-power double data rate memory, is specialized variation engineered entirely for portable devices like smartphones, tablets, and lightweight laptops. It utilizes lower operation voltages and deep sleep power states to drastically reduce energy consumption and preserve battery life. Because these chips are soldered directly onto the device motherboard to save space, they are optimized for thermal efficiency, ensuring your phone stays cool during heavy tasks without requiring a fan. VRAM. Video Random Access Memory is dedicated memory built directly onto a graphic card to handle intense visual rendering tasks. Unlike system memory, which manages general software application, this specialized buffer stores high-resolution textures, 3D models, and frame rate for displays. It featured an incredibly wide data highway, allowing the graphic processor to access massive blocks of visual data simultaneously to ensure smooth, stutter-free gaming and video playback. HBM High Bandwidth Memory is an ultra-premium high-performance architecture used primarily in top-tier data centers, artificial intelligence hardware, and high-end graphic cards. Instead of placing memory chips side by side on a circuit board, this design stacks memory dies vertically on top of each other, connecting them with microscopic wires running straight through the silicon. This vertical stacking minimizes physical distance and allows for an enormous data interface, delivering unparalleled speed while occupying a fraction of the space of traditional hardware.